U.S. warship shredded despite intercepting Russian Zircon. Hypersonic shotgun effect turned victory into disaster in just 12 seconds.
Imagine the North Atlantic in January. It is not merely an ocean. It is a hostile, chaotic, thermodynamic engine designed to strip heat from anything living and fracture anything built by human hands. We are in the Denmark Strait, that jagged, freezing bottleneck between Iceland and Greenland. If you were standing on the wing bridge of a destroyer right now, you wouldn't just feel the cold, you would feel a physical assault. The air temperature is 20 degrees below 0 Celsius, but the wind, screaming at 25 knots across the wavetops, cuts that number in half again. The sea itself is in a state of violence known as Sea State 6. That sounds clinical, doesn't it? A number on a chart. But in reality, it means waves the size of 2-story houses, 6 meters of gray, freezing water, crashing against steel every 12 seconds. It creates a rhythmic, nauseating heave that never stops. The hull of the ship, a Flight 2A Arleigh Burke-class destroyer, groans under the stress. This is the USS Gravely. She is an old warhorse. By 2026 standards, her keel laid down when the world was a different place, when the idea of high-intensity naval combat felt like a memory from a black-and-white newsreel. But tonight, she is pitching and rolling in the dark, her bow plunging into the troughs, sending sheets of freezing spray over the superstructure. That spray doesn't just run off, it freezes instantly on contact. It builds up on the radar arrays, on the missile hatches, on the lifelines. It is called topsider icing, and it is a silent killer. It adds hundreds of tons of weight to the top of the ship, raising the center of gravity, making the vessel sluggish, making it want to roll over and stay there. Why is this ship here battling the physics of the Arctic winter? To understand that, we have to pull back from the freezing spray and look at the map. This is the GIUK gap, Greenland, Iceland, United Kingdom. For 80 years, this stretch of water has been the most important naval choke point on the Earth. In World War II, it was where the German U-boats had to cross to strangle Britain. In the Cold War, it was where Soviet nuclear submarines had to pass to threaten the American coast. And now, in January 2026, it is the line in the water once again. But the game has changed. We aren't just hunting submarines anymore. We are staring down the barrel of a technological revolution that has rendered much of our assumptions about naval warfare obsolete. Lurking somewhere in the electronic noise of the storm, hidden by the curvature of the Earth and the blinding clutter of the waves, is the Admiral Gorshkov. She is a Russian frigate, the lead ship of her class, and she represents a terrifying leap in lethality. She isn't just a ship. She's a launch pad for a weapon that defies the conventional rules of interception. She carries the 3M22 Zircon. Let's stop time for a moment and look at this weapon. Really look at it. If you were to strip away the jargon of hypersonic and maneuverable, what you are left with is a piece of engineering that operates on the very edge of materials science. A standard cruise missile, like the American Tomahawk, is essentially a small airplane. It has wings, a jet engine, and it flies at about 500 miles per hour. It's subsonic. You can see it. You can track it. You can shoot it down with a decent gun if you're lucky. The Zircon is not an airplane. It is an aerothermodynamic kinetic vehicle. It launches on a solid fuel booster, a massive stick of explosive chemical propellant that kicks it out of the tube and accelerates it to supersonic speeds in seconds. But that's just the match that lights the fire. Once it hits Mach 3, the booster falls away, and the scramjet ignites. A scramjet, supersonic combustion ramjet, is an engine that shouldn't work. In a normal jet engine, fan blades compress the air before fuel is added. In a scramjet, the forward speed of the missile itself compresses the air. The air enters the intake at supersonic speeds, and fuel is injected into that supersonic airflow. Think about that. It is like trying to keep a match lit in a hurricane. The fuel they use is called Dicillin M. It's not gas station diesel. It's a designer hydrocarbon, synthesized to have a massive energy density, laced with aluminum nanoparticles to make it burn hotter and faster. This fuel doesn't just power the engine, it cools the ship. The friction of flying at Mach 9 heats the skin of the missile to 3,000 degrees Fahrenheit. If they didn't circulate the fuel under the skin to absorb that heat before burning it, the missile would melt into slag before it ever reached the target. When this thing is cruising at 90,000 feet, it is moving so fast, nearly 7,000 miles per hour, that it does something to the atmosphere that feels almost magical. Shockwave heating ionizes the boundary layer, stripping electrons to form a plasma sheath. It creates a sheath of plasma, ionized gas, that wraps around the missile like a cocoon. This plasma absorbs radio waves. To a radar trying to find it, The Zircon can look like a hole in the sky, or a shimmering ghost that jumps from place to place. But this cloak is also a blindfold. The plasma blocks the missile's own sensors. It can't see out. It is flying blind, guided only by inertial navigation, counting its own steps, waiting for the moment to slow down, shed the plasma, and open its eyes to its theory. Now, shift your focus back to the USS Gravely. Inside the Combat Information Center, the CIC, the air is dry, cool, and smells of ozone and coffee. It is a windowless room in the belly of the ship, illuminated by the blue glow of monitors. The men and women in here are staring at screens that represent the Aegis Combat System. This system is the brain of the US Navy. It is designed to track hundreds of targets at once, prioritize them, and kill them automatically if necessary. But the Gravely is fighting with one hand tied behind its back. She is equipped with the AN/SPY-1 DV radar. This radar was a marvel when it was designed in the 1980s. It uses massive octagonal plates bolted to the superstructure to steer radar beams electronically, moving them in milliseconds without any moving parts. But it operates in the S-band frequency. S-band is great for searching vast volumes of sky, and it punches through rain and snow better than higher frequencies. That's good for tonight's weather. But it lacks the precision, the high-definition clarity of the newer X-band radars. Against a normal missile, this doesn't matter. But against a Zircon, it matters immensely. The Zircon flies high, up in the stratosphere, for most of its journey. The Gravely's radar can theoretically see that far, but the return signal it gets from that plasma-shrouded bullet is messy. It glitters. It fluctuates. The computer struggles to build a firm track, a steady lock-on quality data stream that you need to fire an interceptor. The software on the Gravely, Aegis Baseline 9, has been patched and updated with hypersonic filters to try and make sense of this data, to tell the computer that this erratic, blinking ghost is actually a threat moving at 2 miles per second. But software can't change physics. And then there is the kinetic reality of the intercept itself. The Gravely's primary weapon against this threat is the SM-6 missile. This is a brilliant weapon, a missile with its own active radar seeker in the nose, capable of finding the target even if the ship loses lock. But consider the geometry. The Zircon is coming in at Mach 5 or 6 in its terminal phase. The SM-6 is flying out at Mach 3.5. They are closing on each other at Mach 8 or 9. That is nearly 3 kilometers every single second. Imagine 2 sniper bullets fired at each other from miles away. The SM-6 has to calculate where the Zircon will be, not where it is. But the Zircon can maneuver. It can pull high G turns, banking and weaving to bleed off, speed and confuse the defense. If the Zircon zigs when the SM-6 zags, even by 100 feet, the intercept fails. At these speeds, there is no second chance. There is no looping around for another pass. You have 1 microsecond where the 2 paths intersect. If the fuse on the SM-6 doesn't trigger its warhead at the exact right instant, the Zircon slips past. And if it slips past, we enter the realm of nightmare physics. Let's talk about kinetic energy. We often think of missiles as delivery trucks for explosives. The damage comes from the warhead blowing up, but with a hypersonic weapon, the velocity is the weapon. The formula for kinetic energy is 1/2 the mass times the velocity squared. The velocity is squared. That means if you double the speed, you quadruple the energy. The Zircon hits at Mach 4.5, which is roughly 1,500 meters per second. Even if the warhead is a dud, even if the explosives never detonate, the missile itself weighs over a ton. When that much mass hits steel, at that speed, it carries 1.5 gigajoules of energy. To put that in perspective, 1.5 gigajoules is roughly equivalent to the energy released by detonating nearly 400 kilograms of TNT. But it is concentrated in a single point of impact, focused on a spot the size of a dinner plate. This isn't an explosion. It is a phase change. The steel of the Gravely's hull won't just bend or tear. Under that kind of pressure, millions of pounds per square inch, under hypervelocity, impact pressure exceeding the Hugoniot elastic limit, steel undergoes hydrodynamic flow. The missile will flow through the hull like a finger poking through water. And because it is 20 degrees below zero outside, the steel of the hull is suffering from cold embrittlement. Metal gets brittle when it gets cold. It loses its ability to stretch and absorb shock. Instead of denting, it shatters. The impact of the Zircon will send a shockwave through the ship's frame faster than the speed of sound. It will turn the steel, bulkheads, into shrapnel. It will snap pipes carrying high-pressure hydraulic fluid and jet fuel. It will shear the bolts holding the radar arrays to the mast. This is the hypersonic shotgun effect. The missile enters as a solid slug, but the energy of the impact atomizes it, and the hull plating it hits, creating a cone of superheated supersonic debris that blasts through the interior of the ship. It's a shotgun blast, where every pellet is a piece of molten jagged steel moving faster than a rifle bullet. It shreds wiring. It shreds computers. It shreds the human beings standing in its path. So, as we stand on the precipice of this simulation, understand the stakes. This is not a fair fight. It is a math problem where the variables are heat, speed, and the crushing indifference of the Arctic Ocean. The Gorshkov has the initiative. It has the speed. It has the first shot. The Gravely has a radar from the 1980s, a crew exhausted by the storm, and a defensive missile that has to hit a bullet with a bullet in a blizzard. The timeline of the engagement we are about to describe is measured in seconds. But for the crew of the Gravely, those seconds will stretch into an eternity. The first indication of the attack won't be a visual sighting. It won't be a roar of engines. It will be a flicker on a screen, a single pixel of electronic noise that shouldn't be there, rising up from the curvature of the Earth. And by the time the human brain registers that pixel, the math has already been decided. The warship and the Grave are separated by 12 seconds of computer code and rocket motor propellant. The clock starts now. In the Combat Information Center of the USS Gravely, the concept of time has just undergone a phase change. For the last 6 hours, time was dragging. It was measured in coffee cups consumed and the rhythmic heave of the ship fighting the Atlantic swell. But at 0200 hours, time compresses. It collapses from hours into milliseconds. The trigger is a sound, not a visual contact. In this storm, visibility is 0, but a specific acoustic signature picked up by the towed sonar array trailing a mile behind the ship. It's the sound of a hatch opening underwater, followed by the heavy metallic clank of a localized displacement. The Admiral Gorshkov isn't just passing through. She is seeding the channel. She is dropping smart mines, likely PMK-2s, encapsulated torpedoes that sit on the bottom and listen for the acoustic fingerprint of American submarines. This is an act of war. On the Gorshkov, the Russian captain knows he has been heard. The hydrodynamics of the Denmark Strait are tricky, but at this range, less than 40 nautical miles, stealth is a fairy tale. He doesn't wait for a diplomatic cable. He initiates the first strike protocol. Let's look at the mechanics of what happens next inside the Russian vertical launch system. The hatch for cell number 4 blasts open. The 3 M22 Zircon is cold launched? No. That's for other missiles. The Zircon is a hot launch. The solid fuel booster ignites inside the canister. If you were standing on the deck of the Gorshkov, the violence of this event would knock you off your feet. The missile exits the tube, riding a column of fire that is brighter than the sun. For the first 4 seconds, it is just a rocket, climbing vertically, fighting gravity. It pulls 4 Gs, then 10, then 20. It arcs over, nosing down toward the horizon. And that is when the magic trick happens. At Mach 3, the booster is dead weight. Explosive bolts fire. The rear stage falls away into the ocean. The air intake covers on the nose blow off. The scramjet inhales. The air entering the engine is moving at 3 times the speed of sound. Inside the combustion chamber, injectors spray the Distillin M fuel. It ignites instantly. There are no moving parts here, no turbines, no fans. The geometry of the engine itself compresses the air. The explosion out the back is continuous. The missile surges forward like it was kicked by a god. Mach 5, Mach 6, Mach 8. It settles into a cruise at 90,000 feet, riding the thin air, glowing white-hot. Back on the Gravely, the AN/SPY-1DV radar is sweeping the sky. It sends out millions of pulses of S-band electromagnetic energy every second. These pulses travel at the speed of light. They hit the Zircon, bounce off, and return. But remember the plasma. The Zircon is wrapped in that ionized sheath. To the radar, the return signal is dirty. It looks like a patch of rain, or a flock of birds, or a glitch in the ionosphere. It flickers, but the Aegis Combat System is paranoid by design. The software running baseline 9.C2 sees a return that is moving too fast to be weather and too high to be a bird. It applies a Kalman filter, a mathematical algorithm that predicts where a moving object should be based on where it was. The computer connects the dots. It realizes that this glitch is closing the distance at 7,000 miles per hour. The console in front of the Tactical Action Officer, the TAO, flashes red. A symbology appears. Vampire, vampire, vampire. This is the nightmare scenario. The vampire call means an incoming anti-ship missile. The TIO doesn't have time to ask the captain for permission. He doesn't have time to call the Pentagon. The engagement doctrine is set to auto-special. This means the computer has the authority to fire defensive weapons the moment it calculates a kill solution. But here is the friction. The Zircon is high, at 90,000 feet. The Gravely standard interceptor, the SM-2, is designed to kill things lower down. The system needs the heavy hitter. It selects the RIM-174 standard ERAM, better known as the SM-6. The SM-6 is a beast. It weighs 1.5 tons. It costs $4 million per copy. The VLS, hatches on the Gravely's foredeck, fly open. 2 missiles roar out of the cells. Why 2? Because in the world of missile defense, you never trust just one. It's called shoot, look, shoot. But at these speeds, there is no time to look. So it's shoot, shoot, a ripple fire. Now, we have a math problem unfolding in the stratosphere. The Zircon is coming down. It has to. To hit a ship, it needs to turn on its own active radar seeker to find the target in the chaotic waves of the Atlantic. But its radar can't see through its own plasma sheath, so the Zircon performs a maneuver that is its only weakness. It slows down. It pitches up, increasing drag, dropping its speed from Mach 8 to roughly Mach 4.5. The plasma cools and dissipates. The radar eye opens. This is the vulnerability window. The 2 SM-6 interceptors are clawing their way up. They are powered by their own dual-thrust rocket motors. They are flying blind, receiving guidance updates from the Gravely via a data link. Turn left 2 degrees, climb 5 degrees, but then the data link is severed. The Zircon, now active, spots the incoming interceptors. It executes an S-turn. It banks hard to the right, pulling 15 Gs. A 15G turn at Mach 4 is a massive displacement. In 1 second, the missile moves nearly a mile laterally. The first SM-6 misses. It flies through the space where the Zircon was supposed to be, its proximity fuse scanning empty air. It screams past and self-destructs safely in the upper atmosphere. The second SM-6, however, is the Duel 2 variant. It has a more advanced seeker. It sees the maneuver. It doesn't rely on the ship anymore. It goes pitbull. Autonomous active tracking. The interceptor pulls a violent high G correction, straining its airframe to the breaking point. The 2 missiles are now closing at a combined speed of Mach 8. The impact is not Hollywood. There is no massive fireball. At these speeds, high explosives are redundant. The collision is purely kinetic. The SM-6 slams into the forward section of the Zircon. Physics takes over. The intercept is a success. The Zircon's guidance section is vaporized. The warhead is shattered. Technically, the threat has been neutralized. But Newton's first law of motion is a cruel master. An object in motion tends to stay in motion. The interception happens only 4 miles from the ship. The Zircon was heavy, nearly 2 tons. When it shattered, that mass didn't vanish. It turned into a cloud of debris. A dense shotgun blast of titanium, scorched steel, and unburnt solid fuel, all of it still traveling at Mach 4 toward the USS Gravely. This is the hypersonic shotgun. On the bridge of the Gravely, the lookouts don't see the missile. They see a sudden violent streak of light, like a meteor breaking up. And then, the sound arrives. It is a cracking, tearing noise, like the sky itself is being ripped in half. The debris field strikes the ship. It doesn't hit the hull at the waterline. It sweeps the superstructure. The debris is moving so fast that it ignores the Kevlar spall liners and the aluminum bulkheads. It shreds the AN/SPY-1 radar arrays on the starboard side. It shears off the SATCOM domes. It slices through the bridge wings. One large fragment, likely a piece of the Zircon's engine core, impacts the base of the main mast. The kinetic energy transfer is instantaneous. The steel of the mast, brittle from the -20-degree cold, doesn't bend. It snaps. The entire mast structure, tons of radar equipment, antennas, and sensors, collapses backward, crashing onto the helicopter deck. Inside the ship, the shockwave knocks the crew to the deck. The lights die, replaced instantly by the red glow of battle lanterns. Alarms are screaming. Fire alarms, flooding alarms, toxic gas alarms. The ship has been blinded. The starboard radar is gone. The main comms are down. The Gravely is a mission kill. She is floating, but she can no longer fight as an Aegis destroyer. But she is not dead. In the CIC, the backup power kicks in. The screens flicker back to life. The primary radar is offline, but the ship is linked into the Naval data network. A P-8 Poseidon maritime patrol aircraft, flying high above the cloud layer, has been watching the whole thing. It sends a data link packet to the wounded destroyer. It's a targeting solution. The coordinates of the Admiral Gorshkov, the captain of the Gravely, bleeding from a cut on his forehead, dust falling from the ceiling tiles, gives the order. Kill authorization. Salvo logic set. Birds away. Vampires, vampires, vampires. Target designated. The Gravely cannot guide missiles anymore. She can't defend herself. But she can punch back. The Tomahawk Land Attack Missile, or TLAM, has a Block 5 variant. It is the Maritime Strike Edition. It is a subsonic killer. It doesn't scream in at Mach 9. It creeps. 8 Tomahawks burst from the surviving VLS cells. Their boosters drop away, their small turbofan engines spin up, and they drop down to the wave tops. This is the difference in philosophy. The Russian Zircon is a sprinter, fast, hot, and high. The American Tomahawk is a stalker. These 8 missiles drop to 10 feet above the water. In Sibassos, State 6, they are flying between the waves. They are invisible to radar because they are hiding in the sea clutter, the chaotic radar reflections of the storm. They fan out. They don't fly in a straight line. They waypoint, approaching the Gorshkov from 3 different compass points. The Gorshkov's radar, the Parliament Redoute system, is powerful. But it is looking up, searching for high divers. By the time it detects the Tomahawks, they are skimming the crests of the waves, just 6 miles out. The Russian frigate's close-in weapon systems, the AK-630 rotary cannons, spin up. They sound like chainsaws, spewing 30mm rounds. They splash 1 Tomahawk, then a second. But there are 8. This is the concept of saturation. You don't need a superweapon if you have enough good weapons. The 3rd Tomahawk impacts the Gorshkov's waterline, just aft of the engine room. The 1,000-pound warhead, designed to crack concrete bunkers, punches through the relatively thin hull of the frigate. The delay. Fuse triggers 4 milliseconds later, deep inside the ship. The explosion breaks the Gorshkov's keel. In the freezing darkness of the Denmark Strait, the Russian frigate doesn't die heroically. It shudders, loses power, and begins to list heavily to port. The freezing water rushes into the turbine rooms. The lights go out. In these waters, survival time in the water is measured in minutes, not hours. Silence returns to the channel. The USS Gravely is listing too. She is battered, her superstructure looking like it was chewed by a steel monster. She is leaking hydraulic fluid and fuel into the pristine Arctic water. Her high-tech eyes are gouged out. She will need to be towed back to Norfolk, a journey of 2,000 miles. She will spend 2 years in dry dock. The cost of the repairs will be $300 million, but she is afloat. The Gorshkov is gone. This simulation teaches us a brutal lesson about the future of naval warfare. We have spent decades building ships designed to shoot down airplanes. We have built radars to track warheads, but we are entering an era of physics where the interception itself is dangerous, where a defensive win looks a lot like a disaster. The gap between safety and the grave was 12 seconds, and tonight, in the freezing dark of the North Atlantic, 12 seconds was just barely enough. This is the reality of the hypersonic age. It's not about who has the better microchips. It's about who can survive the sheer brute force transfer of energy. We used to worry about the explosive. Now we have to worry about the shrapnel of the speed itself. End of simulation.